The next topic is if we try to study relative atomic mass, or simply speaking, atomic mass. We usually use the symbol AR to represent relative atomic mass or atomic mass. If you see the periodic table, you'll find that for every symbol written there, there is a value written on the top side and a value written on the bottom side. So these values are basically atomic numbers and atomic masses. For instance, it says for carbon, it is 12.011 and 6. For sodium, it may be 11 or 22.9 something and roundabout like this. So if you are considering what is an atomic number here or what is an atomic mass here, so beta, this is atomic mass or relative atomic mass, and these are atomic numbers. And since we have discussed that previously, now we are discussing what is this. So carbon was set as a standard by International Union for Pure and Applied Chemistry, a society of chemists, to measure or to work out the masses of the relevant atoms. Since we all know that atoms are way far too small, so if someone is going to work out a methodology to measure the mass of the atom, so naturally it would be far less. So scientists or me or I can mean these people, they work out with an idea rather not to measure the mass of the atom directly, but to compare it with the mass of carbon. So for example, let's say it's 22.9 here, I can approximate it as 23. So when I say 23 is the AR of sodium, I mean to say that this is basically 23 times 1/12 part of carbon 12. It is initially believed that carbon has 12 parts, and now we can see this, or we can work this thing out, that it has basically 6 protons and 6 neutrons. And so far the mass of proton is almost equal to that of neutron. So they initially figured out that out of these 12 parts, we can assign one part of carbon as the standard. So now every value in the periodic table, let's say we are considering chlorine as 35.5. So this is the atomic mass of chlorine, that is Ar. So now this 35.5 Ar means that this 35.5 is basically timed by one part or mass of one proton or mass of one neutron, that may be close to 1.6 exponent minus 27 kilograms. So in spite of writing these values all the time, they use 35.5 atomic mass unit, AMU, or simply as this. So when we say that what is a relative atomic mass, so relative atomic mass is the whole concept of comparing the mass of an individual atom to that of the carbon. And you can work relative atomic mass by using this formula: mass of an element, mass of one atom of the element over mass of 1/12 part of carbon 12. So using the concept of AR, one thing I forgot to mention, relative atomic mass is different from mass number. Mass number corresponds to how much nucleons or mass of basically not mass, number of nucleons in nucleus of an atom. So mass number can't always can't anytime be a decimal number. It would always be a whole number. But AR, same goes for MR, that may be molecular relative molecular mass. They can be in certain cases in decimals, but but mass number can never be in decimals. So relating the same concept, if you are comparing the mass of one atom to one part of the carbon, we get the relative atomic mass. If you are comparing the mass of one molecule to one part of the carbon 12, we get the concept of molecular mass. Or even that it can be formula mass, relative formula mass. So basically all of these, now what is the difference between a molecular mass and the formula mass, we'll discuss that later on. But for this, for now, we can consider that they are exactly same in mathematical terms. But for those students who know that molecule is basically the idea or the building block of a covalent compound, so we use MR to work for covalent compounds such as CH4, H2O. These are basically covalent compounds. So the masses of these compounds would be molecular masses. However, if you are working with ionic compounds such as NaCl or KCl or MgO, molecular, now these are not molecules since they are ionic compounds, so they are basically the formula units. So we get a formula mass or relative formula mass here. How would we calculate that? I'll come to that. So if we now work out to calculate the molecular mass, relative molecular mass or relative formula mass for any substance, how would that work out? For example, if you are using methane, so we need to find out the masses from the periodic table. Carbon can be approximated as 12, hydrogen can be 1. So since it is one carbon here, so mass of one atom of carbon is 12 times 1 is 12. Since mass of one atom of hydrogen is 1, but there are 4 atoms here, we can see this as H4. So 1 times 4 is 4, and you get 16 as the MR or relative molecular mass. If you are working with, let's say, NaCl, so since sodium has an atomic mass of 23, chlorine has an atomic mass of 35.5. So this is 23 times 1 as 23, 35.5 times 1 as 35.5. You don't need to time it every time. You can simply add these atoms since we are working here on the beginner's level. So we are doing this like this. So this is basically formula mass. Since this had been an ionic compound and this had been a covalent compound. Okay, so this is how you calculate the relative molecular or formula mass. Moving forward, the concept of mole. In chemistry, 1 mole is equivalent to number of particles, these much particles. So for example, if you are counting, if you are discussing considering an element and you count up this much atoms of element, so that much amount wherever this much particles or atoms are considered in an element are done, so we can say that this is 1 mole of this element. Or if you are considering a covalent compound and you are start to count some molecules in that and you end up with again this the same value, then you can say this is 1 mole of that covalent compound, or you can say this it has 6 exponent 23 molecules basically. Same goes for ionic compound. If you have 6 exponent 23 formula units, you can say it is 1 mole. So just as a representation, 1 dozen means 12. 1 mole means 6 exponent 23 particles. These particles can either be atoms, they can be either ions, they can be either molecules, they can be either formula units, anything you are counting on. So molecules or formula units. So we can convert, or we have the formula. I can use N to represent number of moles. This N. is equals to mass of an element over its relative atomic or molecular slash or formula mass, anything like that. So this is how you convert between moles to mass or mass to moles. So we are going to work certain examples out here, such as you have a question. It says how many moles of water are there in 36 grams of it. So basically I have the formula that is mass over, since it is a molecule, so I'm selecting MR. So mass is 36. How would I work out the MR of H2O? So from the periodic table I know hydrogen is 1, oxygen is 16. So this is 2, this is 1, and I get 18 as an answer. So this is 18. So 18 1 and 18 2, I get 2 moles here. So basically, when you're converting from mass to moles, you're going to divide with the atomic, molecular, or the formula mass. However, if you are converting from moles to mass, then you're going to multiply with the atomic, molecular, or the formula mass. So we can have another example, such as question says, what is the mass of 5 moles of carbon? Let's say you have this. So how can we proceed? Again, you need to work out mass. You can have the same formula. This can be now is AR. So this is N is given. This is 5 times AR, that is 12 times mass. So it would be 60 grams as mass. Okay.